Okay, in this video we're going to talk about phases and phasors of waves. As basically a phase is just a nice way of representing a position on any waveform. So we need to start with a wave. So here we go, here's our wave. And we're going to draw a nice waveform on there. So it's helpful to talk about waves and positions on waves in terms of what we call phases, okay, or what phase the oscillation of the particles or what point of oscillation is at any point on the wave. So we need to utilise this concept of a phasor. Now a phasor is just an angle on a circle basically. We can start out with 0 degrees, that will be our 0 degree position. We can then work our way around to that, guess how many degrees that is, no prizes for that, 90 degrees. We go all the way around to there, that's 180 degrees. Then to 270, and then all the way back round to 360. So, just write those on there, 180, 270. So those are arrows on a circle that represent positions. Now we can use that same nomenclature to help us with positions on a wave. So it's quite helpful to realise that at the equilibrium point, at the start of a wave, we would suggest that that position is 0 degrees. And we're happy with suggesting that, so we're going to draw a phase that looks like that. Our arrow starts to rotate around this, and if you imagine that as we move this along, the arrow follows the line upwards. So eventually we get to a point where we have a phase upwards like that, a phase of 90 degrees. We continue the circle round until we reach this point here where we have a phase of 180 degrees then. We carry on, the arrow moves around following the line as you move the phasor across, and we get 270 degrees at that point there. Until we get all the way back round to a 0 degree position, or 360 degrees, which looks like a phasor like that. Nice thing about phasors is they don't just work in degrees, they also work in a quantity called radians. Those of you who are mathematicians may have come across radians. If not, it's great that we're hitting them first in physics because you'll probably understand it better and understand how they're used. So a radian is just basically another measure of angles in a circle basically, and we utilise them as fractions of pi. So pi is 180 degrees. So pi is 180 degrees. So guess what 90 degrees is? Yeah, pi by 2. So pi divided by 2 is 90 degrees. What's 270 then? Well, 270 is what's that? Well, it's 3/4 of the way round. Well, 3/4 of the way round is, for all intents and purposes, 3 over as a proportion of pi. Because remember, we do it in proportions of pi. It's 3/4 of the way round, but that's 1.5 versions of pi. So that's 1.5 pi. Or we could say it's 3 pi over 2, or 3 over 2 pi, i.e. 3/2 of pi. There's 1/2 of pi, there's 2/2 of pi, there's 3/2 of pi. And that's 270 degrees. In lesson, we'll show you a really nice way of converting between radians and degrees using a calculator that requires literally no effort from you. You just need to know how to use your calculator. Let's have a quick look at phase differences then. Phase differences. And this is where my drawing gets particularly awful, but not at the same time. We'll see how it goes. So it's not just about suggesting the position of the wave, it also allows us to suggest a relationship between two waves. So if I draw a second wave on here now, like this, so I'm just going to draw some crosses to allow me to make sure I draw it correctly. Okay, so I've got two waveforms there. They are coherent. What I mean by coherent, it means they have the same wavelength, and they have a constant wavelength as well in this case. Coherent means they have a constant wavelength, and in this case they have a constant phase difference. They don't have a changing phase difference. So what do I mean by phase difference? Well, the best thing with finding phase difference is to look at any point on a wave, okay, and we match up what the phases are at those two places. The standard place is right at the beginning. So at the beginning we've already suggested that the wave for the black line is at 0 degrees. So what's the phase for the red line? Well, the red line phase is 90 degrees at that same point. That means, what's the phase difference? Well, that means it's 90 degrees out of phase with the other line, out of phase with each other. It's also then, it's pi by 2. So we can write it as either of those two values. We can double check that. What's the phase at this position right here for the red line? Well, it's at 180 degrees. Remember, it's on a downward stroke. So what's the phase for the black line? At that same position, well, that is 90 degrees. So what's the phase difference between those? It's still 90 degrees. Okay? And so we're going to give you some practice of finding the phase difference between different values during the lesson.